In this lesson, we look at hypergeometric distributions. In order to understand how hypergeometric distributions work, we're going to have a look at an example first. So in this example, we're looking at a class of 25 students. 15 have a driver's license, and if 5 students are chosen at random, what is the probability that one of them has a license? So here we're looking for the probability that one has a license. So let's get started on the problem. We're going to start just looking at this as a probability problem. So we know that there are 15 students with a license, and we want one of them to have a driver's license. So the probability that x equals 1 is equal to, well, there are 15 students who have a license, so we have 15 students to choose from. And we need to choose one of those students. So that's the number of students that have a driver's license. Again, we're choosing a group of 5 students, or a total of 5 students. We've chosen one that has a driver's license. The other students, if it's a group of 5, there must be 4 of them, have to come from the students that do not have a driver's license. So 15 students have a driver's license. There are 25 students in the class, so there must be 10 students that do not have a driver's license. So these are the number of ways that we can make this group with 1 student that has a driver's license and 4 students that do not. In order to find the probability, we want to divide that by the total number of outcomes. The total number of outcomes here is just the 25 students, and we choose 5 of them. So we can go ahead and evaluate this now. 15 choose 1 is 15. 10 choose 4 is 210. And 25 choose 5 is 53,130. And we can simplify or evaluate the numerator, and we get 3,150 in the numerator. The denominator is 53,130. Again, we can plug that into our calculators, and we get 0.0593. So this is an example of a hypergeometric distribution. Sorry, that's a bad looking 3. Let's see if we can fix that up. So this is, as I said, this is an example of a hypergeometric distribution. And we'll work through how we can find the distribution table and so on. But before we do that, let's have a look here at some key points for a hypergeometric distribution. So how do you know that a distribution is hypergeometric? Well, the first thing is that you're conducting multiple trials with 2 possible outcomes. So those outcomes of success or failure. So either you have your driver's license or you do not. The other thing to note here is that the trials are dependent upon each other. It means you're not replacing or resetting the clock. So you don't take the one student out who has a driver's license and then put them back in. And often the way we think about this is taking a smaller group from larger groups. So that's a way that we can think about a hypergeometric distribution. Let's have a look now at creating the distribution table. Just like you would create a distribution table for a binomial distribution or a uniform distribution, we can do the same thing for a hypergeometric distribution. So here's the same scenario, the exact same example. We found the probability that 1 student had a license. We could also find the probability that 2 of them have a license, and so on. So here's the value that we found earlier, right in here. So that's the result that we found. If we want to create the distribution, we find all of the values for the random variable. So there were 5 people on the that were selected, 5 students that were selected. So our possible number of students with a driver's license were 0 to 5, and we calculate the probability for each of those. So just like we calculated on the previous slide, the probability of 1 person having a driver's license, we do the same thing for 0 people, 2 people, 3 people, 4 people, and 5 people. Once you have the probabilities, you can take the x values, multiply them by the probabilities, and we would get the x times p at x column, and our expected value is located right down here. So this means that if we chose 5 students, we would expect in the long run that 3 of them would have a driver's license. Again, once you have this table, you can create a graph, bar graph, either by hand or using a spreadsheet. Both can be done, and you can see how that works. Alright, so the next thing that we need to talk about is this expected value. We can find the expected value by making a table, but sometimes that's a little long and a little bit tedious. So what I want to do is just kind of look at a shortcut that we might be able to take. Don't get me wrong, the table will always work, always give you the right answer. It can just be long sometimes. So let's look at the expected value. So in this case, the expected value was 3. That means that in the long run, if you were to repeat this experiment a whole bunch of times, where you pull 5 students from this list of 25 students where 15 have a driver's license, well, if we think about this for a second, we know that 15 out of 25 students have a driver's license. And we're going to we want to know how many of them would have a driver's license if we were to pull 5 students out. Well, this is really just a ratio, and we can find that here, in order to go from here to here, we divide by 5. So we must have to do the same thing here. So we get 3 over here. So that's not a surprise that the answer was 3. But a short way of doing this, the ratio certainly works, but typically the expected value, or the formula for expected value, is given as e at x is equal to n, the number of trials, let's try that again. So the number of trials times the probability that our event, our desired outcome, happens. So this is the number of trials, and this is the probability of the success. So probability of a success. And in our case, a success was somebody having a driver's license. So out of the 25 people, 15 had a driver's license, this value kind of right up here. So really, if we were to do this, we did 5 trials, 5 students were chosen, and the probability of success was 15 out of 25. We can simplify this, divide 5 from both the numerator and the denominator, and we get 15 over 5, which works out to just 3. Now, since we're looking at equations here, we should probably also look at the equation for a hypergeometric distribution. So we did it just kind of logically working through, but there is an equation that goes with that as well. And generally, that equation looks something like this. It looks a little bit cumbersome at first, but once you match it to the example that we just did, it starts to make a little bit of sense. So the probability that x equals x is just equal to, and I'll label all of these variables in a second because there are a lot of them here. A choose x times b choose n minus x, and all of that is divided by a plus b choose n. So if you think about that example that we did a while ago, or this example here, I guess, with the 25 students, these were our desired outcomes. Let me just label this. These were our desired outcomes. We wanted to know about the people with a driver's license. Outcomes. Well, our committee, or our group of 5 students, couldn't be just made of students with driver's license. It also had to be made with students who didn't have driver's license. So these were sort of the undesirable outcomes, or the failures, I guess, because we did say that we were talking about success and failures. So these were the undesirable outcomes. Undesirable. Sounds so negative. And this here is just the total number of ways that we can make a choice. So I said we would define some of these variables, so let's go ahead and do that just so you can see what those are. So in this case, A is the number of successful outcomes. I think I can squeeze this in down here. Maybe I'll change colors. A is the number of successful outcomes. So in our case, it was the number of students, the total number of students with a driver's license. B is the unsuccessful outcomes. Again, it's the number of unsuccessful outcomes. What else do we need in this equation? We need the n, which is the number of items being selected, items or outcomes. In our case, it was the group of 5 students. Let's call it the number of selections being made. And don't forget, x is the random variable, so the values, x would be these values from the table here. So if we wanted one person with a driver's license, x would be 1, and so on. So I think we got them all. We've got a, we've got b, we've got n, and then we talked about x being the random variable. We probably should have defined our random variable up here. I guess we didn't do that. Let x represent the number of students with a driver's license. So really, it's the number of chosen students with a driver's license. With a license. So that's how we can do a hypergeometric distribution. You can do the table by hand, so the table that we have created, you can do it by hand, obviously, and you can also use a spreadsheet to make that table just by using the built-in combin function in a spreadsheet. So easy to do in a spreadsheet as well.